Good evening, good afternoon, good morning from wherever you're joining us from today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney. Welcome to another Microsoft Reactor Sydney live stream event. Today I would like to welcome Will. Will is a software engineer from ASB Bank and a Microsoft Data Platform MVP. In this evening's session, he'll show you how you can integrate Cosmos DB into your Azure Functions using triggers, bindings, and dependency injection, and vice versa. He will also cover the do's and don'ts when developing Azure Functions that use Cosmos DB. This session will be approximately 60 minutes with about 10 to 15 minutes of those for questions at the end. However, please do send us your questions throughout in the Q&A and we'll try to answer as many as possible. At the conclusion of this session, I'll also share with you the link to our feedback survey in the Q&A section. Your feedback will help us to create our topics that better suit our audiences, so please take the time to fill this out if you can before dinner. Also, if you'd like to reference this session after today, a recording will be uploaded to our YouTube channel. But for now, I'd like to give the floor to Will to begin. Will, over to you.
Awesome. Thank you so much, Sarah. Hello, everyone. It's great to be back at the Reactor. My name is Will Valida. I'm a software engineer and Microsoft Data Platform MVP based in Auckland, New Zealand. And welcome to this session, Building Event-Driven Applications with Azure Functions and Azure Cosmos DB in C#. So I'll start off this evening by going over what Azure Cosmos DB and what Azure Functions are. So it doesn't really matter if you haven't heard of them before or if you're using them in anger and production scenarios. This will just be a quick overview just to kind of introduce or recap what these two technologies are. And then I'll go over how they work together, why they work so well together, and how we can use them in different ways using bindings, using triggers, and a little bit of dependency injection, and where we would use them, how we would use those three different ways of interacting with each other in different scenarios. Then I'll discuss some cloud patterns that we could potentially use Azure Cosmos DB and Azure Functions for, and how we can actually use those two technologies to implement some of those cloud patterns. And then we'll dive into some code and I'll actually show you some C# code, how they fit together, so how bindings work, how output and input, how output and input bindings work, how triggers work, and how dependency injection works using an actual example. So if you have any questions, just pop them in the chat and at the end I'll answer them then. Cool, so let's start off with Azure Cosmos DB. So Azure Cosmos DB is Microsoft's globally distributed multi-model database service. And using Cosmos DB, we can build databases that use a variety of different data models. So if we're building applications that use document data, we can do that using either the SQL or the MongoDB API. Perhaps we might be building applications that interact with columnar data, and we can use the Cassandra API for that. Perhaps we're using key value data on applications. Cosmos DB provides a table API, which is essentially Azure table storage, but just on a globally distributed scale. Or perhaps we're building applications using graph data, and Azure Cosmos DB offers that that supports graph data via the Gremlin API. Essentially, whatever models or whatever data you're working with in your Cosmos DB environments, it provides you the ability to build highly responsive and available applications worldwide, ensuring that no matter where your users are, you can replicate or bring your data as close to them as possible. And there are a lot of key benefits of Cosmos DB. So like I said, Cosmos DB replicates your data to wherever your users are. It's a foundational service in Azure, so no matter which Azure region in the world you're deploying your resources to, you can create a Cosmos DB account, and you can add and remove any Azure regions to your Cosmos DB account at any time. What Cosmos DB will do, it will replicate your data to all regions associated with your account while your application continues to be highly available. It also offers you elastic scalability for both your reads and writes all across the globe. You can scale up to thousands to millions of requests per second and only pay for the throughput that you need to deal with any spikes in workload. There's guaranteed low latency at the 99th percentile. So with Cosmos DB, you can build highly responsive planet scale applications, and it guarantees less than 10 millisecond latencies for both index reads and writes at the 99th percentile, which is really great because that allows us to, it provides us really rapid queries and really responsive applications. With Cosmos DB, you no longer have to choose between two consistency extremes. So with distributed databases, we're usually faced with the choice of eventual consistency or strong consistency. But Cosmos DB provides a little bit more flexibility than that. It provides 5 well-defined levels of consistency for us to choose from, depending on the needs of our application. And with a little bit of caveats, there's no schema or index management. So right out of the box, Cosmos DB will automatically index all of your data and is schema agnostic, meaning that you don't have to worry about application downtime or managing any schemas or indexes on your database. There are some edge cases where you might need to worry about index management, and just because it's schema-less doesn't necessarily mean you throw the idea of data modeling out of the door, but essentially index management is handled for you. And moving on to Azure Functions. So Azure Functions is a serverless solution that allows us to just focus on writing our code, maintaining less infrastructure, and save on costs. So instead of worrying about deploying and maintaining servers, the cloud infrastructure provides us with all the up-to-date resources that we need to keep our applications running. It provides compute on demand, and it allows us to implement logics in blocks of code. And as our requests increase, functions can scale with as many instances as required. And functions are really, really flexible. So we can use Azure Functions to react to events, we can schedule tasks, we can process and consume messages, and we can also write to databases. Essentially, you focus on the pieces of code that matter the most to you, and Azure Functions handles the rest. And by using Azure Functions, you don't have to build, you have to create a full-blown application to respond to changes in your Azure Cosmos DB database. Essentially, with Azure Functions, you can create small reusable functions for very specific tasks. And you can get instant access to all your data in Cosmos DB, so you have granular access to every value because Cosmos DB will automatically index all your data by default and makes those indexes immediately available. So this means you're able to constantly query, update, and add new items to your database, and Azure Functions allows us to have instant access to our data in Cosmos DB. Like I said, data stored in Cosmos DB is schemaless, so it's able to handle any output from an Azure function. This approach makes it very straightforward to create a variety of different functions that can output to Azure Cosmos DB and also read from Cosmos DB databases. It's very scalable as well. So in Cosmos DB, throughput can be scaled up and down instantly. So if we have hundreds or thousands of functions querying and writing to the same container, you can actually scale your Cosmos DB containers to handle that load. And then all of the functions can work in parallel using the allocated resources on your Cosmos DB containers, and your data is guaranteed to be consistent. And with global replication, you can reduce latency and geolocate your data closest to where your users are. And as with all Cosmos DB queries, data from event-driven triggers to read data from Cosmos DB, we can bring that as close to the user as possible. There's no limits to Azure Functions as well, so functions can execute in parallel and the service spins up as many services as you need. You just define the parameters and the limits for that. And just at a real basic level, it's really integrating Azure Functions and Cosmos DB together is really, really good for quick tasks. So the service will actually spin up new instances of the function whenever an event fires, and then close them as soon as the function completes. And we only pay for the time that our functions are running. So if we need to just do a quick lookup in our database, but we only need to do for a very short amount of time, we can do that really, really easily with Azure Functions. So how do they work together? So the different ways that Azure Functions there are different ways that we can use Azure Functions to interact with our Cosmos DB database. So we may want to execute a function whenever a document is created or modified in the collection. and we can use a Cosmos DB trigger to do that. We might want to do a quick read on our collections based off a very simple SQL query, and we can use input bindings for that. Or we might want to do some writes to our Cosmos DB collection, and for that we can use an output binding. So let's try and visualize this a little bit more, starting with event-driven functions using the change feed. And this is done by the Cosmos DB trigger. And this is a really, really simple way of using a feature in Azure Cosmos DB called the change feed, which I'll explain in a bit. But essentially here, what we've got is we can set up a function with a Cosmos DB trigger to listen to our container in our Cosmos DB account. And every time a document is created or updated, our function will be invoked, and we can produce an output based on those changes. So just extending this with a little bit of an example, let's say if we have a function called purchase product, and every time we have an e-commerce site, and every time a customer creates an order, we can use the change feed to produce an output depending on what we might want to do. So for example, we could use the change feed to persist our document to another collection in Cosmos DB that might have a different partition key. We might want to take our JSON document and store it in colder storage that might be more suitable to analytical workloads. Or perhaps we want to take it to another, we want to get our JSON documents and put them into a workload that's optimized for machine learning capabilities, such as Azure Databricks. And we might be able to perform some machine learning jobs based off the changes in our collections. Essentially, any changes that occur within our container, they're produced as a sorted list of documents that the changes were made in order that they were modified. Now, with the change feed, we aren't limited to just a single consumer. So it's not like we have to set up multiple change feeds in order to do different things. All of these consumers can consume the same change feed to do some parallel processing. So just taking this example, we have a function using purchase product that gets persisted to as a product document gets persisted to that collection. We might set up different change feeds, or we might do we might set up the same change feed, but then set up different consumers, such as a backup collection as Azure Storage as a cold storage option, or Databricks to do some parallel processing. Now, Azure Functions aren't the only way that we can work with a change feed. There is also a processor library that the Cosmos DB team have provided, but that's a little bit out of scope. So with that, that's a real quick introduction to what the change feed is. I've got a demo that actually showcases this a little bit later. So let's return to our bindings. Now, we can use an input binding to read data from our Cosmos DB collections. So for example, we might have an Azure function that uses an HTTP trigger as part of a serverless API to perform a particular query that retrieves data from our Cosmos DB account. We can then use that output to return documents to our users as part of a web page. Essentially, if we need a subset of our data in a Cosmos DB collection, we can use input bindings to execute really simple queries in order to get that data back to us. And we can also write to our Cosmos DB containers via output bindings. So taking our serverless API as an example, we might have an HTTP trigger making a post request in an API, or we might want to read events off an event hub that we want to consume and then persist to Azure Cosmos DB. So we can easily set up a Azure function with a Cosmos DB output binding to write data to our containers. Cool. So that was a really quick overview of what input bindings, output bindings, and triggers are in Azure Cosmos DB. And we see how they work together. So let's dive a little bit deeper now into how we can actually use Azure Functions and Azure Cosmos DB to implement some cloud patterns. And I've added a link there to Microsoft has got this great set of documentation where they actually describe, they actually cover a lot of cloud patterns that go into a lot of depth. But I'm only going to pick 3 cloud patterns that we could use Azure Cosmos DB and Azure Functions together, just as an example. But if you are thinking of, if you're building applications in the cloud and you're looking for some best practice, I'd really recommend checking that out just for some guidance on some good patterns. But let's start with event sourcing. So Instead of what event sourcing essentially is, instead of storing just the current state of the data in the domain, event sourcing, we can use an append-only store to record the full series of actions taken on that data. And then the store acts as a system of record that can be used to materialize our domain objects. And this can simplify tasks in very complex domains by avoiding the need to synchronize the data model with the business domain, while it being able to improve performance, scalability, and responsiveness. We can also provide consistency for transactional data and maintain full audit trails and history that can enable compensating transactions. So here I've got a very, very basic diagram which kind of illustrates this. So let's say we are building a payment system, and we've got a bunch of different microservices that handles the processing of a payment. So we might have a function that creates the payment. When we create that payment, we persist that payment at that time to a Cosmos DB container. And let's say, for the sake of an argument, that a payment has a status. So it might have a created status, a validated status, updated, etc., etc. Essentially, as our payment goes through our application, hitting different microservices, every time an action is taken on that payment, we can actually use event sourcing to persist to our Cosmos DB data with an updated status of what's happened to that payment. So we might want to update a payment. We might have a function that updates the payment that persists it to a Cosmos DB, the Cosmos DB container. We might want to cancel a payment if we don't want to buy something, and that microservice then tells the database, okay, this payment's now cancelled. Using event sourcing, we can maintain an audit record of what's happened to that payment using event sourcing pattern. So, and that's that's just one example of how event sourcing can work. And then using Azure Functions and Cosmos DB to do that is really straightforward. The second pattern I want to talk about is command and query responsibility segregation, or CQRS for short. Essentially what this pattern does, it separates the read and update operations for a data store. So implementing CQRS in your application can help maximize your performance, scalability, and security responsibilities. In traditional architectures, the same data model is used to query and update a database. And that's simple, it's straightforward, and it really works well for basic CRUD operations. But as our applications become more complex, this approach can be a little bit unwieldy. And what CQRS does, it separates the reads and writes into different data models using commands to update data and queries to read data. And these commands should be task-based rather than data-centric. So if we're booking a hotel room, we should say we book a hotel room, not set the reservation status to reserve, for example. Commands may be placed on a queue for asynchronous processing rather than being processed synchronously, and queries never modify the database. Essentially what a query does, it returns an object to us that doesn't really encapsulate any domain knowledge. And then materialized views. What this does, we can generate populated views over data in one or more data stores when the data in its original format isn't ideally formatted for the queries that we're required to perform. And this can really help us support efficient querying and data extraction and improve the application performance. So when we're storing data as developers, we often think about how the data is going to be stored as opposed to how it's going to be read. And this is a consideration when we're actually building our applications. But this can have a negative effect on how we perform those queries. When a query only needs a subset of data from some entities, such as a summary of orders from several customers without all the order details, we'd have to essentially extract all of the data for the relevant entities in order to get that information back to us. And to support efficient querying, a common solution is to really generate in advance a view that materializes the data in formats that's suited to our queries. So taking this example, we might have a container that's purely optimized for writes. We might be hammering this thing hard, just performing millions and millions of writes per second. And then using another function that's triggered by Cosmos DB, using a Cosmos DB trigger, we can actually take all of our writes in that container and produce a more efficient model for querying into a read optimized store. And that's one way we can implement materialized views using Cosmos DB and Azure Functions. Cool, so let's jump into a demo. So I'm glad I hope I'm sharing my screen, but let's. Cool, all right, so Sarah, can you see my Visual Studio?
Yeah, I sure can.
Fantastic. Awesome. Now, I always get anxiety whether I'm sharing a screen or an application in Teams, and I'm glad that I've managed to hit this on the head. Okay, so essentially what I've got here for this demo is I've built this kind of hypothetical IoT device reader. So here I've got a bunch of functions that generate device readings, generate devices. We're going to be doing some materialization, producing materialized views. We're going to show basically send events via a post request to Event Hub and Service Bus, and then take that reading from Service Bus or Event Hub and stick them in containers. And I've also got a little serverless API that uses bindings here. So first up, what I want to show you is this startup file. So from version 2 of Azure Functions, there's support for dependency injection. So now, one of the things that you have to think about when you're comparing using bindings and dependency injection, when you're using bindings, I'll actually get the bindings functions out. So here I've got, here I'm using an HTTP trigger. I've got an input binding for my Cosmos DB account. Now, this is great for doing real quick and efficient tasks, but the problem with this is my Cosmos DB client that I'm using for this function is only scoped to this function. So every time I invoke it, I'm essentially connecting to that database again and again and again each time I'm invoking the function. And this client is limited to this function. I've got another function here. This client will be limited to that function. And what dependency injection does, it actually allows us to share our Cosmos DB clients, or any clients that we're interacting with Azure Functions, allows us to share that across the lifetime of our application. So what I've got here is I'm just loading my configuration file here, just a local configuration file. And here I'm defining some client options for my Cosmos DB account. And what I'm for my connection, sorry. And the great thing about this is what we can do with this, we can actually configure our Cosmos DB clients, and that would apply to all of our functions that use the Cosmos DB account for the lifetime of the application. So here I'm just setting the connection mode to direct, but here I can set the consistency level. I can do some custom handling if I need to. I can set some retry options. Serialization, set some proxy, and then that would apply to all of the that would apply to the Cosmos DB client, and then that gets used across all the functions within my function application. Cool. So what I'm going to do, let's start off by generating some readings. Okay, so what I've got here, this just uses an HTTP trigger. So I'm going to be using Postman to just generate some device readings. I've got some fake, I've got this class that actually generates some fake device readings for us. And essentially what this does, this will send it to an event bus queue. This will then trigger off another function. Let me find it. Process readings. There we go. Okay, so then all as messages are getting sent to the service bus queue, this will then invoke this service bus trigger, and this will add all the messages on that queue into this container that I've set up. So I've set up some repository classes just to kind of abstract the logic, but essentially what this does, this will add it to a container for our devices. And I've got that read store. So I've got a bunch of containers here in Azure Cosmos DB. And I've got one for device readings here. So essentially what we're going to do, I'll just go back to that one. I'll put breakpoints, and then what will happen here? This this container, sorry, has been optimized for writes. As we can see, it's partitioned by ID. And then I've got another container here called device core, and that's partitioned by location. So say if we're performing very quick queries and we want to get devices by a location, I have a function that does that for us. And essentially this is possible through this materialized reading functions. So essentially this uses Cosmos DB trigger, which is the change feed, and it's listening to this device readings container. And it uses a lease container as well. So essentially, think of this lease container as a checkpoint within the change feed. With this, we can actually configure our change feed function to read from the beginning if we want to. And this kind of like overrides the lease container. And so it just ignores the checkpoint and it goes right to the start of the lifetime of that container. But yeah. Just exploring this a little bit more before I start this off. So even though our Cosmos DB client is limited, or when we're using bindings and triggers, it's scoped to our functions, we still have the ability to configure our functions depending on what we need for that particular function. But again, just remember or just keep in mind that any configuration that you do at the function level will only be scoped to that function. Cool, so just that, sweet, no compile errors. All right, so what I'll do, I'll just kick this off. I'm going to be using Postman to test this. So I've got generate devices, generate readings. All right. So just looking at the code again, it's building up. Hopefully it's not going to take too long. There you are. All right, I'll just put that down. Hopefully it will just show me once it's started up. So essentially all the functions hopefully will be ready soon. But what I'm going to be doing, I'll send that post request to this generate readings function. This will generate a bunch of readings that will get sent to service bus. And then once service bus, once they get sent to the queue, that will invoke this function here. And we're going to add it to our write optimized store. So to make sure I'm pressing the right buttons, fantastic. Cool. Move that breakpoint, and then I'm just going to put a breakpoint here, press continue. And then as documents are getting added to that container, hopefully what should happen, it's executing. So it's definitely executing, but my breakpoint's not getting hit. But essentially what's happening is when our writes are happening, when items are being created, oh, hello. Just having a slight nightmare with my demo. Never mind, I'll just stop it for now and just explain it. So essentially what's happening when that when changes are being made to that container, they're essentially getting added to this read-only list of documents. And what we can do with change feed functions, with just a few lines of code, we can iterate through this list. So we're first checking if there's any documents that's been added at all. And if there has been, for each document within our list, we can basically do whatever we like with that document. So here I'm just deserializing this object into a device reading object that I've got here. And then I'm saying, okay, once you've deserialized that, once that's all successful, add it to my read optimized container. And there's the end result. I built it earlier, so, but yeah, anyway. Cool, all right, So once we've had our materialized data, what we can do now, I've got a device, got a simple device bindings API, I've called it, but essentially these are just functions that use the bindings. So what I can do, let's put a benchmark here. So now that we've got our materialized view going, we can now use our bindings API to perform some really simple perform some real simple queries. So if I just type in New Zealand, hopefully this will return all the documents in New Zealand back to me. So I've hit my breakpoint there. Oh, there you are. Not sure what's going on there. I'll just remove the breakpoint. Hopefully that works. Oh, that's not the right API. What's going on there? That's okay. Let's go back to our bindings API, get them by location. Am I hitting the right endpoint? Yeah, I am. Let's try a different location. So I'll try Italy, see what happens. From device readings. Okay. Never mind. Yeah, let me talk through this while this is not working. So essentially what this is supposed to be doing, here I've got my HTTP trigger. So essentially I'm just defining, okay, on GET requests with this route, what I want you to do is just essentially use this Cosmos DB input binding. So this is the database I want to query. This is the collection I want to query as well. And here's my connection string setting. So I've got my connection string in my local settings file. But again, you can store this in app settings or you can have it in Key Vault. And here I want to perform, when I invoke this function, this is the query I want to perform. So here I'm just selecting all the device readings where the location is equal to the location that I give it. And essentially what this does, this will just return the object back to us if we can find it. And we've got a very similar thing going on here. So with this, I've got again an HTTP trigger that's just performing a GET request, but this time I'm passing in an ID. And instead of a SQL query that I'm defining here, we can actually, if we know the ID of our documents, we can just pass that into a parameter called ID. And then we can pass in a partition key. And if your partition key is different, so say if it was for this one, location, I can actually append this by going, just typing in location. So when I'm making that GET request to a particular ID within a location, I can pass through, I can just set this configuration up, and this will return the object back to me. That's reading or using input bindings to read documents, but we can also create, we can also write to Cosmos DBs via output bindings as well. So here it's a very simple setup. So I've got my database name, the collection I want to write to, and my connection string setting. And essentially what this does, it's essentially we're writing it to this iasync collector of device reading. So I'm passing in an input. I know this one, it worked earlier, like it definitely worked earlier. So let's try it again. Let's see if we can succeed or fail. Succeed for the first time or fail for the second time. That'll be interesting. So essentially what we've got is I'm reading the input that I pass in. So I'm passing in my payload. I'm deserializing that to a device reading. Let's use the one I used earlier. So here's my request body that I'm going to be passing through to my API. And essentially I'm just saying, okay, add it to this list, which is going to persist it to my Cosmos DB account. So let's try, I'm going to just mix it up, use Italy. And hopefully, oh boy. All right, cool. There we go. All right, sweet. So there's our input. Let's hope it actually works. So we're reading in our input. We're deserializing that into a device reading. And then we can add it to our Cosmos DB account. Well, container, I should say. And there's our 204 response back to us. So if we look in our database, if I look in the core, hopefully, we should see, if I just order by time descending, and there's our document stored in Azure Cosmos DB. So that's a really, really simple way of setting up a function that can just write to a Cosmos DB container. If we have an application where we know we're not going to experience a lot of traffic, we've got very low traffic, low amount of users, we can use bindings to set up a very simple, straightforward endpoint that just essentially says, okay, whenever a user provides us some input, write that input to a Cosmos DB account. So rather than building a more sophisticated Azure function such as this process reading one, here I've added a lot of abstraction to it. So I've got this device repository class that handles most of the heavy lifting for us. But instead of having to do all of that, we can literally just write 10 or 15 lines of code, depending on how complex our input is, to write to a Cosmos DB database. Cool. All right, so exploring the materialized view pattern a little bit. So what I've got, I'll just start this up again. Essentially what I've got is I've got another function that generates actual devices, so not the readings, the devices themselves. And this is all fake data. And this gets sent to an event hub. And depending on, with each device, they have a property for how much damage they've incurred. And depending on the damage level, we can either write that to a container that essentially says, okay, this device is ready to be deployed, or we can send it to table storage, where we essentially say, okay, these devices have a high level of damage, here's their ID, let's put them on a list to repair them. And essentially, this is possible through that dependency injection. So if we go back into our startup file, here I've got this table helper class, which essentially defines a connection to Cosmos DB table storage. So with dependency injection, this actually gives us a lot more flexibility in the types of Cosmos DB accounts that we can use. With the bindings, with the Azure Function bindings and triggers, we're limited to the support for the SQL API. So with dependency injection, we can actually open up our function application to MongoDB API accounts, or in this case, table API accounts, Graph, Cassandra, whatever account that you might be using for your whatever API you might be using for your Cosmos DB account. So it provides us a lot more flexibility in that regard. So let's go through that. So here I'm just generating a bunch of devices, but this time I'm sending it to Event Hub. And then I've got this assess device damage level function. So if we will read the incoming device, if the damage level is high, we'll send that to an Event Hub to process those high damage devices. And if not, we'll send it to a low or medium damage Event Hub. And then using this Cosmos DB table helper that I've created, we can actually insert what I've done here is I'm taking the incoming event body, deserializing that into a device object, and then I've got this device entity that just essentially gives me the ID, or persists, sorry, the device ID and how old the device is into a table storage account. So what I'll do is kick off that generate function, and then I'll switch to my table API account, just give it a bit of a refresh. And here we can see, rather than the full device object, what I've done is I've actually materialized a view. here saying, okay, there's the ID and there's how old the device is. And then we can actually use that information perhaps to kick off a process where we repair those devices. But if those devices are fine, I've got another container here that essentially just shows me all the devices that have suffered low or medium damage and they're ready to be deployed out into the field. And then from here, we can actually create another function that actually listens to this write optimized container and then do something with those events to actually deploy those devices out into the field. Cool. All right, so let's start from here. I'm going to show you the slides, not my notes. I hate it how PowerPoint does that, but never mind. Okay, cool. Oh, I've duplicated. Never mind. So if you want to check out the code for that, looks good from there. Fantastic. Yeah. Okay. Thanks for that. I was worried there for a second if I thought I might just wing it, but thanks for not letting me do that. That's all very appreciative. If you want to check out the code for that, to explore it a little bit more in depth, or if you want to clone it down yourself, have a bit of a play around, maybe come up with your own solution based off that, there's a link to that project there. Cool. So if you want to learn more, here's a bunch of resources, and I'm going to put this in the meetup group as well, in the event comments, just in case you miss it. But essentially, gotcosmos.com is a fantastic place to start when you're first experiencing, you're trying to learn about Azure Cosmos DB right from the get-go. It's got some fantastic architectural guidance, use cases, resources to material on Microsoft.learn. It's a real fantastic one-stop shop for all Azure Cosmos DB. I've put a link to the introduction to Azure Cosmos DB there. That's also worth checking out. They've got the developer team from Cosmos DB. They've set up their own dev blogs on Microsoft, and that's a really fantastic place to find out what's happening in the Cosmos DB space in terms of releases, new capabilities, and also developer advice as well. There's also documentation there for Azure Functions that I've put up there. And I've also shared this serverless library.net. This is a great community resource where there are tons and tons of samples of using Azure Functions, not just with Cosmos DB, but I've seen some samples that use MongoDB, cognitive services, the timer triggers, if you want to learn how timer triggers work, Event Hub, Service Bus. And if you're looking for if you're looking for a variety of different samples, that's a great place to go and check out. And it's open source as well. So if you're developing Azure Functions or applications that use Azure Functions and you want to contribute a sample to that, you're free to go ahead. Cool. So thank you so much for joining me. Yeah, let's dive into some questions.
Great, thanks, Will. We've just got a couple of questions that have come through. So first question was from Jay. Is Cosmos DB an interface to other proprietary DBs, or is it in of itself a DB like DynamoDB? Did you get that?
Yeah, that's an awesome question. It is. I wouldn't describe it as an interface to other. I wouldn't describe it as such. If you take the MongoDB API, for example, the idea is that you can have your data sitting in MongoDB, and essentially you can just switch to Azure Cosmos DB without changing your code at all. It's just a connection string that you change. There is a caveat to that, depending on what version of MongoDB you're using. So they try to do some parity with the latest version of MongoDB, but I think they're not quite there yet. I'm not too sure in the case of Cassandra. Yeah, I think that kind of answers your question. It's really dependent on the API.
All right, great. Thanks for that question, Jay, and thanks, Will. We've got one more question from Chandra. So how to trigger an Azure function that gets called only when a new document is added or deleted from the Cosmos DB container? Question mark.
So I think, if hopefully I'm interpreting the question right, I think that question is asking, can you isolate the change feed on a particular operation? The answer at the moment is no. So essentially a workaround for this is what the Cosmos DB team recommend is essentially add a flag within your document that kind of acts as like a soft delete. So when you're performing deletes on those operations, when you're performing operations on those documents, essentially you add a property to your document saying this document was deleted, and then as you consume those documents into the change feed, you can perform queries within your functions to say, okay, for all of the changes within that container that have this soft delete flag, then you can process from them. But unfortunately, at the moment, there is no support for just isolating operations. I hope I've interpreted that question correctly.
Great, thanks, Will. Look, we do have one more question come through from Shakar. However, can you see that in the Q&A section?
I can.
Yeah. Did you want to? That's quite lingo-y.
Sure. Is there a chance of SQL injection from Postman? The user can give 1 + 1 = 1 in device bindings API. So we have SQL query select all from device readings where c.location is equal to location. That's a good question. That's not something I've attempted myself. So I'm gonna just say I'm not sure. But I'm not too sure how to answer that. Sorry, Sakar.
No worries, all good. Well, I think that's it for us from the question side of things. So thank you so much, Will. Like you said earlier, for everyone that's still with us, Will's going to pop his extra links in the Meetup event page. And I'm just going to pop into the Q&A section right now a link to our survey and just a link to our Sydney Meetup page and just our YouTube channel. So we're going to upload this one to YouTube if anyone wants to refer back to it in the next couple of days. It should be uploaded within the next 48 hours. So thanks again, Will, and thanks for everyone for tuning in tonight. It was very informative, and we hope to have you back on again soon.
Cool, awesome. Thank you so much for having me.
Great, thanks everyone, and have a good night.